The Anthroquine process, developed by German chemist Clemens Winkler in 1876, is a key industrial method for producing hydrogen peroxide. Hydrogen peroxide is a versatile chemical with applications ranging from disinfection, bleaching, to wastewater treatment. Its importance is particularly underscored in its role as an eco-friendly oxidizing agent, contributing significantly to reducing the environmental impact of various industries.
So, cool thing about hydrogen peroxide is that it's nice and bubbly, and that it's a good oxidizer at high concentrations. That actually wasn't that bad.
Hello, and welcome to today's episode of How to Make at Home. Today we're making hydrogen peroxide with Anthroquine process. The Anthroquine process involves several steps. Anthroquinone is a powder derived from organic chemical sources. Hydrogen is also derived from organic chemical sources. Hydrogen peroxide is produced through extraction and purification, like distillation and filtration. Firstly, we get the anthraquinone, usually in solid powder form. Here we have it mixed into a liquid form in a small beaker. Next step is the hydrogenation of anthraquinone, where hydrogen gas is combined with anthraquinone in this reaction. Anthraquinone plus hydrogen molecule is gonna react into hydrogenated anthraquinone. This step is usually done with a catalyst, like palladium, to speed up the reaction. After this comes the next step, the oxidation to produce hydrogen peroxide, where oxygen reacts with organic matter of hydrogenated anthraquinone. Hydrogenated anthraquinone plus oxygen molecule will be equal H2O2, which is hydrogen peroxide. In the end, hydrogen peroxide is separated with fractional distillation from the water that could have accumulated through the combination of hydrogen and oxygen. This cycle is usually run under specific conditions, temperature ranging from 20 degrees Celsius to 40 degrees Celsius, and pressures around 5 to 30 bar. This process requires a catalyst for the hydrogenation step, typically palladium or nickel, as already have been mentioned, until we get only hydrogen peroxide and anthraquinone that can be removed later. Reactants like anthraquinone and hydrogen are derived from organic chemical sources. The hydrogen peroxide produces extracted through extraction and purification processes, including filtration and distillation.
The Anthroquine process is efficient and pretty good, both environmentally and economically. So, first of all, the competitor to this process will be electrolysis of ammonium persulfate, right? So, where the Anthroquine process wins environmentally is that it actually goes very quickly, and it's a very simple procedure. You get anthraquine, you hydrogenate it on a palladium catalyst, you then combine that with oxygen, and boom, you get your hydrogen peroxide. This is a pretty simple reaction, and it produces pretty pure hydrogen peroxide, 30%. Now, in comparison, electrolyzing ammonium persulfate is way more difficult. You need to add additives like barium oxide to remove silver additives, which you added to remove other impurities from the thing that you got from your electrolysis. This isn't exactly efficient. You're using a lot of other reactants, and overall, this makes your process way less environmentally good. Second of all, we obviously know that electrolysis is very heavy on energy usage. Now, energy usage is not exactly a good thing for environmental sustainability, right? Energy equals CO2 almost, unless you're running off of renewable sources. Electrolysis takes a lot of energy. In comparison, the Anthroquine process takes less energy, so it's more environmentally safe. However, the Anthroquine process does release aromatics and a lot of wastewater. Now, this is a problem because you have to clean the wastewater and scrub out the aromatics. However, overall, this has been managed to be done efficiently and safely. Therefore, overall, the Anthroquine process is very good environmentally, or at least in comparison to its current competitors. Future competitors to the process may be a lot better. So economically, it actually holds the same virtues. In comparison to the complex vacuum distillations and additives of the other hydrolysis process, the Anthroquine process is actually significantly more simple. Anthroquine is pretty cheap, and overall, we get hydrogen peroxide from it that costs about $1.50, right? Like in comparison, you've heard about the Haber process. Ammonium costs about $50 per kilogram, and there's an order of magnitude more ammonium produced. So I think in terms of economies of scale and quality, hydrogen peroxide is very good. Now, another thing that's good is that this process gives us instantly 30% by weight hydrogen peroxide. This is a nice purity in comparison to the other processes, which usually give impure and contaminated hydrogen peroxide. So this makes it much easier to distill because usually there's just water left. And overall, this makes it much more economically viable. Now, there are problems. It does use quite a bit of energy, right? Not as much as electrolysis, but it is quite energy expensive. Additionally, the palladium catalysts that are needed to hydrogenate the anthraquine are quite expensive. However, there is research into other catalysts. Overall, I think it's a good and very economically safe process. Otherwise, we wouldn't have been using it for decades, since the 50s at least. Overall, the Anthroquine process is a very economically effective and relatively simple process. Uh, my probable estimation of the future is that it'll be used for at least 10 more years. But there are alternatives. There are new catalysts using alumina, silica, as well as acids that could be added to change the properties of the catalysts. Beyond that, there are approaches like direct synthesis, which cut down on waste like wastewater and aromatics. Overall, if these approaches were further developed and made industrial and scaled, the price of hydrogen peroxide will be even lower, and it'll have a positive effect on the environment. So overall, the Anthroquine process is quite efficient for both the environment and for the economy, right? Most of our industrial products, which use hydrogen peroxide, or all of them actually, like bleaching products for textiles and precursors to other chemical reactions, they all come from the Anthroquine process. However, it can definitely be improved upon, and I believe it will.